Hello, this is the video tutorial for drawing the slotted sector as an oblique drawing. To begin, I'm going to move the right side view away from the location it's at now, so we have more room to work. I'm going to turn off the dimension layer. I'll make the object layer current, and we will begin. There are different angles in which you can draw an oblique drawing at 30 degrees, 45 degrees, and 60 degrees. Before we start, let's draw lines in those orientations to decide which one we want to use. I'll use the center line layer for that purpose. I'll start here, make sure my angles are on. There's 30, 45, and 60 right here. So I'll keep it at that polar tracking of 15 degrees. 30 degrees is here. 45 degrees and 60 degrees. The part has a cylindrical object that will extrude forward, so I'm going to project 30, 45, and 60 in this direction also. What I'm going to do is see which option is best by using the copy command and extruding along the length of these lines. The distance of the cylinder going forward is going to be 1.25, and the depth of the part going backwards will be 0.5. The depth of the cylinder and the part is based on the type of oblique drawing we're going to use. A cavalier drawing, which is at full scale, or a cabinet drawing, which is at half scale. Being that the thickness is not much, we have 0.5 going back and 1.25 going forward. Let's draw this as a cavalier, or full scale. I'm going to use my red center lines as a reference point. And along each line type in 1.25 to find that location. To see which one looks best. So let me copy this over. I'm going to turn off the center lines briefly. Copy. Will be these two circles from here. This is at 30 degrees. I can quickly use tangent snapping to see what my oblique would look like at 30 degrees. Be a lot of trimming to do there, which I'll take care of later. So that's at 30 degrees. Let's take a look at the others. Redraw my tangent lines. Alright, even before we trim, which one do you think looks the most realistic in this case for the drawing? It's like 60 degrees is much too far. 45 doesn't look bad. I have a feeling 30 degrees is going to be the nicest of the three possible angles. We have to copy this back 30 degrees as well, so I will need to draw a line. Let's try here. There's 30 degrees that way. The depth is 0.5. depth of the part is 0.5. Let's copy this back and see how it looks. We're going to copy from this intersection to that endpoint to copy the base of the slotted sector. Let me make sure I have my snaps on that I need. I'll need this one. Alright, let's begin. So copy, pick the features of the back of the part, and the slot itself will be copied backwards. The interior cylinder will not show up inside, so I do not need to copy that back. Enter, my base point is going to be this intersection. It's going to snap to that endpoint right there. Alright, there'll be a lot of trimming involved. You won't need to see that step. However, you'll see that the video here will be edited out as I stop the video briefly, just so that I can trim everything which you don't need to see. After which, I'm going to show you how to finalize the appearance of this drawing, such as the line we need to draw here or anywhere else that requires a connecting point between the parts, just like we did with the cylinders. I'm going to turn the center line back on, remove all of my different angles that I had. No dimensions are required on a pictorial drawing, so please remove those as well. Then this object, this cutting plane line will become a center line. None of this information is relevant. Nor is this. But we do need to add more center lines across the face of this front of the open cylinder. Extend them at 0.25 distance in all directions. Okay, so the remaining parts that we need are going to be lines along here, which I believe will be our tangents again. So let's take off the others and let's draw those lines. Deferred tangent to deferred tangent. There it is right there. Trim that off. And the other location will be down here. So deferred tangent to deferred tangent. Let the program find that point for you, and then trim off this feature right here. Alright, this looks like our oblique, so let's get it ready for printing. Remove all this, put a paper space, Z enter, 1XP enter, it fits nicely. And this is the drawing as an oblique.